Hey guys, how's it going? We've got a real challenge today. The question comes from a standardized aptitude test to gain entry into a US university and tests everything you know about quadratics and algebraic manipulation. Let's have a look at it. So here's the question. We have x squared over root of x squared minus c squared. That is equal to c squared over root of x squared minus c squared plus 39. In the given equation, c is a positive constant. Which of the following is one of the solutions to the given equation? A minus c, b minus c squared minus 39 squared, c minus square root or negative square root of 39 squared minus c squared, or d negative square root of c squared plus 39 squared. So let's rearrange this first to make it simpler. What is the original equation? X squared over root x squared minus c squared is equal to c squared over root x squared minus c squared plus 39. Let's bring all the variables to the left-hand side. X squared over root of that thing minus c squared over root of that thing is equal to 39. Now notice that the two fractions there have the same denominator, so let's combine them. X squared minus c squared over the root of x squared minus c squared is equal to 39. If we square both sides, we get the numerator squared, x squared minus c squared squared, over the denominator, which is just x squared minus c squared, is equal to, on the right-hand side, 39 squared. Now, we can cancel a factor of x squared minus c squared from the numerator and denominator on the left. That gives us just x squared minus c squared equal to 39 squared. Now that we have our simple rearrangement, let's look at the solutions. Solution A is minus c. Substitute that into this equation. Bracket negative c bracket squared minus c squared is equal to 39 squared. Is it true? Negative c squared is just c squared. So on the left we have c squared minus c squared, which is 0. 0 is equal to 39 squared. Clearly false, therefore negative c is not a solution. Let's skip ahead to solution C. Solution C is minus square root of 39 squared minus c squared. Plug that into the equation. So we have open bracket minus root 39 squared minus c squared, close bracket. All of that is squared. Minus c squared is 39 squared. Now, when we have a square root or a negative square root and we square it, we just get what's under the third sign. So we get 39 squared minus c squared. Minus c squared equals 39 squared. Let's work that out. That simplifies to 39 squared minus 2 lots of c squared is equal to 39 squared. The only way that can be true is if 2c squared is 0, meaning c is 0. However, that conflicts with the condition in the question, which is that c is a positive constant. Therefore, c cannot be 0. This is not a solution. Let's look at option D, negative square root of c squared plus 39 squared. Well, once again, when we substitute that in as a solution and we square it, we just get what's under the root sign. So we end up with c squared plus 39 squared minus c squared is equal to 39 squared. Simplifying, the two c squareds cancel, and we end up with 39 squared equals 39 squared. That statement is true, and that allows c to be anything, which means it can be a positive constant stipulated in the question. This is our answer. Finally, we get to option B, minus c squared minus 39 squared. Let's substitute that into our equation. Open bracket, minus c squared minus 39 squared, close bracket, all squared. Minus c squared equals 39 squared. Now inside that bracket, we've got two negatives. We turn those into two positives. When we take the square, it will be the same because the square of a negative is equal to the square of a positive. We get open bracket c squared plus 39 squared, close bracket, squared. Minus c squared equals 39 squared. When we have a square of a binomial, the rule is we square the first, so c squared to the power of 2. Then we have plus twice the product, plus 2 times 39 squared, c squared. Then we square the last, plus 39 squared to the power of 2. Minus c squared equals 39 squared. Bringing everything to the left-hand side, we end up with c squared to the power of 2 plus 2 times 39 squared minus 1 in front of c squared plus 39 squared to the power of 2 minus 39 squared, all equal to 0. So we end up with a quadratic in c squared. So we have the coefficient for the c squared squared term, and for the c squared term, and the constant term. So those are our values of a, b, and c. The quadratic formula states that x is equal to minus b plus minus root b squared minus 4ac over 2a. Plugging in values, first for the discriminant, that bit under the root, we get b squared minus 4ac. Substituting values for a, b, and c into that, we get 2 times 39 squared minus 1, all of that squared, minus 4 times 1 times 39 squared to the power of 2 minus 39 squared. When we work that out, we get a pair of multiples of 39 to the power of 4 and 39 to the power of 2, which cancel, and we get 1. So we end up with minus 2 times 39 squared minus 1 plus minus root of 1 all over 2. And that gives us minus 3041 plus minus 1 over 2. And the two answers we get are minus 1,521 and minus 1,520. Remember, this is for a variable c squared. So if c squared is to be negative, that means that c cannot be an element of R. Hence, there are no real solutions. Therefore, this solution does not work. In conclusion, the answer to this question is option D, negative square root of c squared plus 39 squared.